All right, this problem is asking us to solve for the exact values of secant theta, cotangent theta, and sine of theta. Given that we have an angle in standard position whose terminal side intersects the circle at the following coordinates. So the first thing you want to do is graph this. So even though you can't tell exactly where negative square root of 13 over 7 falls, we do know that we're going in the negative, or to the left of our origin, and y is positive, so we know we're going up. So this would be the ordered pair. Negative square root of 13 over 7, 6/7. So that gives us this point here. So what we want to do now, since we're looking to find the exact values, that means no calculator. So our next step is to determine this side, and we would have to do that using the Pythagorean theorem. So remember, c squared is equal to, or that's the hypotenuse, is equal to 6 over 7 squared plus square root of 13 over 7 squared. So I'm going to go ahead and do a little math here. So 6 squared is 36 over 7 squared is 49 plus square root of 13 squared is 13 over 7 squared, which is 49. So now we have 36 plus 13. So that gives us 49 over 49, which is 1. All right, and we kind of expected that because it says it's a unit circle, and a unit circle always has a radius of 1, but I wanted to show you why that was the case. So the next thing you want to think about is, where are these trig functions positive and negative? So in a previous video, I've talked about where sine, cosine, and tangent are positive and negative. So in this first quadrant, everything's positive. In the second quadrant, sine and cosecant are positive. In this third quadrant, tangent and cotangent are positive. And in this fourth quadrant, cosine and secant are positive. So now all we need to do is find the exact values. So secant of theta is equal to 1 over the cosine of theta. These are reciprocal trig functions. So it's equal to 1 over the cosine, which means if cosine of theta is equal to adjacent over hypotenuse, secant will be equal to the ratio of hypotenuse to its adjacent side. So the hypotenuse here is 1. So we have 1 divided by square root of 13 over 7. And remember, when you divide by a fraction, you flip and multiply. So that's going to be 1 times 7 over the square root of 13, which is equal to 7 divided by the square root of 13. And in this quadrant, only sine and cosecant are positive, so we know that this has a negative value. Okay, so again, just as a quick review, secant of theta is equal to the ratio of a triangle's hypotenuse to its adjacent side, cosecant is equal to hypotenuse over opposite, and sine is opposite over hypotenuse. So we're going to use this to help us finish this problem. So we have already solved for the secant of theta. Secant of theta was equal to hypotenuse over adjacent, which was square root of 13 over 7. So that's 1 divided by the square root of 13 over 7. So that's 1 times 7 over the square root of 13. So secant of theta, just trying to get that a little bit neater. There we go. So secant of theta is equal to 7 over the square root of 13. And in this quadrant, secant is negative. Okay, let's now look at cosecant. So cosecant is positive in this quadrant, and that's equivalent to the ratio of the hypotenuse, which is still 1, over opposite. 1 divided by 6 divided by 7. Flip and multiply, that gives us 7 over 6. And that's going to be positive because cosecant is positive in the second quadrant. And then sine of theta is equal to opposite, the ratio of its opposite side to its hypotenuse side. So sine of theta is equal to 6 over 7. Sine is positive in this quadrant, so 6 over 7 is the answer.